Alright, this is 5-7, day 2, and today we're going to talk to some about patterns. Our objectives are to write an equation using function notation and to explore the Fibonacci sequence. We're going to work on the first objective on your video today, and then the second part, the exploring the Fibonacci sequence, we're going to do in class tomorrow. Alright, you're going to write this with linear functions. We have f of x equals the change in y over the change in x times x plus f of 0. So you're going to write this part right here down. We're going to use that for every single problem that we're going to do. So f of x equals, and this little thing right here is just delta. It's a Greek letter delta. It means change in. So the change in y over the change in x, which is the same thing as slope, times x plus f of 0. The f of 0 here is just our y-intercept, because we know if it's a y-intercept when x is 0. Alright, so again, please make sure that you have this part written. In words, you don't have to write this part. So the function equals the change in y values divided by the change in x values times x plus the output value when the input is 0. But again, you do not have to write that part. We just want to see this part.
It's a whole lot of words just to explain the top.
Alright, go ahead and copy the table. It says write an equation using function notation with f and find f of 6 using the equation. So go ahead and copy that table down.
So you're copying down this. So we're going to come back to our equation, and you're going to write this down. F of x equals the change in y over the change in x times x plus f of 0. And now we're going to find the change in x, the change in y, and the f of 0. So we're going to look at our table here that we've been given, and we're going to find out what the change in x is first. Alright, so we have to figure out what our change is, just like we did when we were doing arithmetic sequences. So you have to figure out what you would add to -4 to get -2. If that's challenging to you to think about it in terms of negatives, you can come to the positive side, and usually if you're looking at positives, you can make more sense of it. So think about what you would add to 2 to get to 4. I'm pretty sure you all know that if you were to add 2 plus 2, you're going to get 4. If you were to add 2 to 0, you're going to get 2. -2 plus 2 is going to give you 0. And -4 plus 2 is going to give you -2. So you can see that our change in x is +2. That's the delta sign there, by the way. So again, you've copied this table, and you need to write there the 2's out to the side and show that your change in x is +2. Now over here, you have to think about what you would add to -14 to get -8. Again, it may be easiest to come to the positive side and look at 4 to 10. In order to get from, oh shoot, sorry, I pushed the button. In order to get from 4 to 10, you would be adding 6. From -2 to 4 is +6. From 8 to -2 is +6. And from 14 to -8 is +6. If you are unable to figure out what you're adding each time in order to get to the next number, you could also do like we did with arithmetic sequences and take the second term and subtract it from the first term in order to find the difference. So now I'm going to fill in my rule. I have f of x. Well, I'll let it come in. Hold on. Nope. Alright, so I'm going to fill in my rule and function notation again. This part of it is not going to change. The f of x equals blank over blank x plus blank. Basically, these are just blanks. Now, I'm going to fill in my change in y, which I've determined over here at my table that the change in y equals 6. So my change in y is 6. And my change in x is 2, and my f of 0 is found by coming over here to the table and finding my value of y when x equals 0. So my f of 0 is -2.
And guys, to find that, all you're doing is looking at your table on the x side, and you're looking for the 0. So on the x part of the table, you're looking for 0, and then when you find the 0, you're going to look to the y part of the table. Whatever is on the y part of the table across from 0, that's going to be your f of 0.
So what this means here, this 6 can be divided by the 2, so that gives me f of x equals, that gives me 3x plus -2 or -2. And I'm not exactly done there. I have found the equation in function notation, but the directions up here say then find f of 6 using the equation. So in order to find f of 6 using this equation, I simply have to go back in and plug in 6 for x. So, again, the f of 6 is nothing more than a name. And it doesn't affect the problem or change the problem in any way because it's just the name. F6 just means that whenever I have an x in my rule and function notation, I'm just going to plug in a 6 for the x. So that's going to give me 3 times 6 plus -2. 3 times 6 is going to give me 18. I'm going to change my plus -2 to -2. And then my final answer here, 18 minus 2, is going to give me 16. So f of 6 equals 16. And that is the second half of the question, where it asked me to find the f of 6 using the equation. All right, so just make sure that you have that down before you move on. All right, number 2 says write an equation using function notation, then find f of -18 using the equation. The first thing I need you to do is copy down this table. Make sure that you leave 2 rows at the top of the table empty. We're going to come in and fill those in later, but make sure that you get this table copied down, but you leave these 2 rows at the top of the table empty. So you have x, and then you have 2 blanks, 2, 3, 4, 5, and 6. And then in your y column, you have 2 blanks, followed by -3, -2, -1, 0, and 1. The first thing we have to do again is to fill in our rule and function notation, which means that we're finding the change in y and the change in x. So in order to find the change in y and the change in x, we have to think what is happening from 2 to 3 to make it go from 2 to 3. We're adding 1 here. Plus 1. From 3 to 4, plus 1. From 4 to 5, plus 1. And from 5 to 6, plus 1. So my change in x equals 1. Now my y, from -3 to -2, you may be able to see here that you're adding 1. If you're not sure about it, come down to the 0 to 1 and you'll see you are in fact adding 1. From -1 to 0, and from -2 to plus 1. I'm sorry, from -2 to -1. You're adding 1. So my change in y equals 1. I'm going to fill in my change in y, which is 1, and my change in x, which is 1. But now I have my f of 0. In order to find my f of 0, I simply have to look back at the table and find where x equals 0. The problem here is that I don't have x equals 0 anywhere on my table. So I have to fill in the blanks to get to the point where I know what y is when x equals 0. So I'm adding 1 each time. So in order to find the next value down, I'm going to subtract 1, and it's going to give me 1. 1 to 2 is positive 1. Now again, in order to find the next value, I'm going to subtract 1, and it's going to give me 0. 0 to 1 is positive 1 again. Now I have to do the same thing to find out what y equals when x equals 0, so I'm going to subtract 1 to find the next term and then do it again to find the next term. Oh, sorry. I did that backwards. And that's why you have to think about what you're doing. All right, so it's -4 and -5. All right, so my f of 0 I can now fill in. I can see over here on my table, if I can find where my mouse is, I can see over here on my table that when x equals 0, y equals -5. So my f of 0 is -5. And that should be a negative sign there, not. All right, so f of x equals 1x minus 5. That is the rule in function notation, but the catch here is that the question asked me to find f of -18 using the equation. So I have to plug in -18 everywhere I see x. F of -18 equals, again, that's nothing more than a name, 1 times -18 minus 5. So 1 times -18 is going to give me -18 minus 5. -18 minus 5 is going to give me -23. So f of -18 equals -23. Make sure you have all that down before you move on.
All right, number 3 says write an equation using function notation. It says on your notes, write when given a graph, make a table of values. You do not have to draw this graph over here. So this time we're given a graph, and they're wanting us to write a function. So we're going to take this graph and make a table. But again, you do not have to draw the graph. Just write on your notes, when given a graph, make a table of values so that you know what to do when you're given a graph tomorrow on your assignment. All right, so what I'm going to do is I'm going to take and I'm going to pick the points off of this graph, and I'm going to make a table with them. So I'm going to make my x and y table, and I'm going to pick my points off. This point right here is -2, 2. This one is -1, 0. This one I didn't go left or right at all, so it's 0 and then -2. And then this one is 1 and -4. So again, all I did was pick the points off of the graph, and I made a table of values. Now it looks just like number 1 and number 2 that we've already done. So you should have your table of values written, and also when given a graph, make a table of values written on your notes for number 3. All right, again, we're going to go ahead and write down our function notation. F of x equals the change in y over the change in x times x plus f of 0. And just like we've done before, we need to fill in those pieces of information. The 3 things we have to find are the change in y, we have to find the change in x, and we have to find the f of 0. To find the change in y, I'm going to figure out what am I adding to 2 to get 0, what am I adding to 0 to get -2, and what am I adding to -2 to get -4. And again, if I don't know, I can take the second number and subtract the first one, just like we did in arithmetic sequences. And here I'm actually adding, I'm adding -2, because 2 plus -2 is 0. 0 plus -2 is -2. -2 plus -2 is -4. So my change in y here is -2. So I'm going to go ahead and plug that in for my change in y. Then I'm going to find my change in x. So I'm going to go back to my table and figure out what am I adding to -2 to get -1, -1 to get 0, and 0 to get 1. So that's my change in x. And here I'm adding 1 each and every time. Now I can check this in my calculator, and I can say -2 plus 1 and make sure it gives me -1. -1 plus 1, make sure it gives me 0. 0 plus 1 is 1. So my change in x is 1 because I'm adding 1 each and every time. So far we have our change in y is -2, our change in x is 1, so we have -2 over 1. Our final piece of information is this f of 0. So on our x part of our table, we're going to look down through here until we find the 0. Right, here's our 0, and we're going to look to the right of it and say, what is our y when our x is 0 and it's -2? So I'm going to go ahead and circle that, so that way I know my f of 0 is -2. So now we have all of our different pieces to our function notation. So basically now we're just going to simplify it just a little bit. We're going to say negative 2 divided by 1 is negative 2, and plus negative 2 is just minus 2. So f of x equals negative 2x minus 2 for number 3. And number 3 does not have an extra part to it, I don't believe. Nope, so we're going to leave it right there. It didn't tell us to find any values or any f of a certain number here. So we're just going to leave it with writing function notation, and this is our function notation right here. Please make sure that you have all of that written before you move on. All right, number 4 says pickup sticks were arranged to create pentagons as shown. Write an equation in function notation to determine how many sticks it would take to make 32 of these pentagons. Go ahead, pause the video, take a minute, draw you a little sketch of this. Okay, it does not have to be perfect, but draw you a little sketch.
Just make sure that your figures have the same number of sides that the figures in the drawing do.
All right, hopefully you've paused the video and taken time to draw the picture of the pentagons. We're going to make an X and Y table from our pentagons and our pickup sticks. We're going to make an X and Y table. The X here is going to be the number of the figure, and the Y is going to be how many sticks it takes to make that figure. So if we only have one pentagon, we're looking to see how many sticks does it take to make one of these pentagons. Well, it takes 5. So we're going to do 1 and 5. We're going to leave one blank up here for the f of 0 part that we're going to figure out later. If you look for my second pentagon, it's going, and we're going to count the number of sticks again. And since it's actually sharing here, they're connected with 1. I'm going to count how many total, and it's going to give me 9. So to make 2 pentagons, it's going to take 9 pickup sticks. To do 3 pentagons, it's going to take 13. To do 4 pentagons, it's going to take 17. And to make 5 pentagons, it's going to take 21. So from here, after you get your table done, it's pretty much just exactly like what we've been doing in the first 3 examples, but we had to make that table using our picture first. So here we have f of x equals the change in y over the change in x times x plus f of 0. So again, we're looking for those 3 pieces of information. So over here we're going to say, what do we have to add to 5 to get 9? Or we can also say, how many pickup sticks were we adding each time to get the next figure? And we were adding 4, so that's our change in y is 4. Over here, each time we were going up by 1 figure. So over here, our change in x is 1. So we're going to say 4 over 1. Now, we don't know what our f of 0 is, and a lot of times we look at it and we automatically think, well, if there's no figure, then there's no sticks. Okay, that's not necessarily the case. We may have sticks, but we don't have enough to actually make the pentagon. So we actually have to still work backwards in our table. And if I work backwards in my table, this goes to 0 because 0 plus 1 is 1. Here I say, what do I put here that if I add 4 I get 5, and that's 1. So 0 and 1. So here I can find my f of 0. And my f of 0 is 1. So I find 0 on the x part of my table, and I look to the right to my y, and it's 1. So I'm going to plug in the 1. And now I'm going to clean that up just a little bit and say f of x equals 4x plus 1, because 4 divided by 1 is 4. So there's my function notation. That was the first part of my instructions. The next part asks, how many sticks would it take to make 32 of these pentagons? I don't know about you, I don't want to have to draw 32 of them. So we're going to use our function. So if our figure is 32, instead of x, we're going to plug in 32. So we're going to say f of 32, and everywhere we see an x, we're plugging in 32, because we want to know how many sticks for 32 of these. So we're going to say 4 times 32 plus 1 gives us 128 plus 1, which is 129. So if we were going to make 32 of these pentagon shapes, it would take us 129 pickup sticks. Please make sure you have all of this written before you move on. You need to have your pickup sticks, your pentagons drawn. You need to have your table, and you need to have where we filled in for your function and where we put in the 32. All right, number 5. Again, take a minute and pause the video and draw these F's with the blocks. Blocks were arranged to create the letter F as shown. Write an equation in function notation to determine how many blocks it would take to make the 10th F. So go ahead and draw these first 3. All right, hopefully you've paused the video and taken a minute to draw each one of these so that you have those in your notes. And again here, just like we did with the pickup sticks, we're going to do the same thing with the blocks. We're going to make an X and Y table. And again, X is going to be the number of the figure, and the Y is going to be the number of blocks, because how many blocks it takes depends on the number of the figure that we're wanting. So for the first F, we're going to count the blocks. We have 1, 2, 3, 4, 5, 6, 7, and 8. So for one figure, it's going to take 8 blocks. Then we're going to count the blocks in the second figure. So for the second figure has 12 blocks, so we put 2 and 12. And finally, for the third figure, we count the blocks, and there are 16 blocks for figure number 3, so we write 3 and 16 in our table. Again, make sure that if when you drew one, if you missed a block, please make sure that you fill that in. Make sure your first one has 8, your second one has 12, and your last one has 16. So again, from here, it's exactly like what we've been doing with all the other examples. We're going to go ahead and finish filling in our table, it looks like. So here we say, okay, we're adding 1 each time to get the next figure, so we have a 0 here. And here it looks like we're adding 4 each time, so we're adding 4 blocks. 4 plus 4 is 8, 8 plus 4 is 12, 12 plus 4 is 16. Okay. If you do not have the blocks written, please make sure you pause the video now because they're about to go away. All right, so we have f of x equals the change in y over the change in x times x plus f of 0. So again, we're going to plug in each piece of information here. We already talked about our change in y being 4 because that's what I'm adding each time. So each time I add another f, I'm adding 4 more blocks. So that's 4. Each time I'm adding 1 figure, so that's 1. And my f of 0 means if I don't have any f's, I have 4 blocks left. So plus 4. 4 divided by 1 is 4, so we're going to say f of x equals 4x plus 4. That's our function. That's the first part of our instructions. Now it wants to know if we were going to make 10 of these f's, how many blocks, or the 10th f would have how many blocks in it? Not how many it would take to make 10, but the 10th f, how many blocks would it have? So instead of x, we're going to plug in 10. So we're going to say f of 10 equals 4 times 10 plus 4. So every time we see an x, we're going to plug in a 10. 4 times 10 is 40, plus 4 is 44. So if we were to make the 10th block would have 44 blocks to make it. Make sure you have all that written before you move on. All right, number 6, write an equation using function notation. How many blocks are needed to make the 9th figure? So again, take a minute, pause the video, and write down or and go ahead and draw these block figures. All right, hopefully you paused the video and taken time to actually draw these because you're going to need those for your notes. Again, we're going to make an x and y table where x is the number of figure and y is the number of blocks it takes. So we're going to count our blocks. This first block right here has 8. We're not counting the one in the middle because it's not shaded, so there are 8 blocks in the first one. There are 14 blocks in the second one, so 2 and 14. And there are 20 blocks in this third figure, so 3 and 20. So again, now that we have our table, it looks just like what we've been doing. And we're going to say f of x equals the change in y over the change in x times x plus f of 0. Over on the y side, we're adding 6 each time because 8 plus 6 is 14, 14 plus 6 is 20. Again, if I can't automatically see that, I'm going to take 14 and subtract 8, and it's going to give me 6. So our change in y is 6. Our change in x is each time we're adding 1 new figure, so that's 1. Now we need to work backwards in our table to find our f of 0. So we say, what can we put right here that if we add 6 will give us 8, and that's 2, because 2 plus 6 is 8. So now I can see that this is my f of 0. Again, to find that, you find the 0 in the x part of the table, and you look over to the right. Whatever y is your f of 0, so my f of 0 is 2 here. Again, clean this up just a little bit. F of x equals 6x plus 2. So there's our function. Now it says if we were going to make, if we were going to go all the way to the 9th figure, how many blocks would that 9th figure have? So we're going to say f of 9. So everywhere there's an x, we're going to put a 9. So here 6 times 9 plus 2 gives me 54 plus 2, which is 56 blocks. So if we were going to make the 9th figure, if we kept going with this pattern, would have 56 blocks. Make sure you have that written before you move on. Alright, so there's our first objective, is to write an equation using function notation. And again, tomorrow in class we're going to explore the Fibonacci sequence for a few minutes. So this is the end of your video. Thank you for watching.